Okay, well, I'm going to go through the trapezoidal rule to show people how you can do this, and hopefully it will help if you have any confusion. All right. So a popular problem that you're given is that you have the integral from 0 to 2 of x squared dx. And what you're going to do is we're going to use the trapezoidal rule of n equaling 4. That means you're using 4 trapezoids to try to estimate what this definite integral is. Okay, so we're using, whenever we have that, we're using 4 trapezoids. So, to do this, the first thing you might want to just think about is you might want to graph this. I apologize for my graphs, but we have a parabola, x squared. So what we're going to do is we're integrating this x squared. We're going from 0 to 2. Alright, 0 to 2. So right here, I'm going to create 4 different trapezoids along this curve. So first off, what we're going to do is, the trapezoidal formula is 1/2, alright, the height times the sum of the bases, b1 plus b2. Okay, so to do this, the easiest, well, I don't know if it's the easiest way, but if you just think about this, is that we're going to create 4 different trapezoids along the center. So the first thing is that the trapezoids, this is going to be our length, our height of each of our trapezoids. And our height is found by usually finding delta x. Delta x in this case is b minus a over n. And so here, our b is 2, our a is 0, and our n, we know, is 4. So we're going to take 2 minus 0 divided by 4, alright, and we get 1/2. Okay, so we have 1/2 is each one. So from 0 to 1/2, I'm going to have a trapezoid, okay, from 1/2 to 1, from 1/2 to 3/2 to 2, another trapezoid. And so what we have is we have a trapezoid here, we'll have a trapezoid there, we'll have a trapezoid here, and then we'll have a trapezoid for that last one. We're going to fill those in. Okay, so for the first trapezoid, to do this, we're going to plug in our values. So we have right here, if we say f of x equals x squared, just so we use f when we're creating this. So trapezoid 1 is going to be 1/2 the height, which is 1/2, all right, times the sum of the bases, which in this case is going to be f of 0, so that's the first one, and then plus f of 1/2. And we plug it in. We're going to add that to our second trapezoid. So once again, 1/2 times our height, which is 1/2, but now our bases in this case are going to start from 1/2 to 1. So we're going to have f of 1/2 plus f of 1. All right, we're going to keep on adding our different trapezoids. We have 2 more to go. Trapezoid 3, all right, is going to be 1/2 times 1/2, because that's our height, times our base. Well, in this case, our second one is going to be starting at f of 1 plus f of 3/2, and we'll plug that in there. We're going to add that to trapezoid 4. Our last trapezoid is right here. So what we have is 1/2 times our delta x, which is our height, which is 1/2, times f of 3/2 plus f of 2, our last base. Now, from here, you might have the trapezoidal rule, and you might have written this down in your books, or you see it in your book, or your teacher's written down. However, really, all you're doing is you're adding trapezoid areas together. Now, you might realize if they're all uniform, that means they all have the same delta x values, which doesn't always happen on AP tests and whatnot, not necessarily in all in real life. But in this case, we all have uniform values. So if we do that, we could actually factor out 1/2 and 1/2. So I'm just going to make that 1/4. And let's just say we factor that out of each of our values. Now, what we have left over is we'll have f of 0 left over. Plus, we'll have f of 1/2, then we're going to add another f 1/2. So actually make 2 f's of 1/2. What we have right there. We'll then have f of 1, and then another f of 1. So actually have 2 f of 1s. Okay? Plus, then we have, yes, another one of 2 f of 3/2. And then we'll have, finally, our f of 2, which is our last base, our last endpoint. We have that. Okay. So from here, to finish this up, is we actually just need to plug these values into f. So you can use your calculator or whatnot. So we plug in 0 into f squared. So if you recall, f equals x squared. So we have 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 4. We will then add these together. Half plus 2, and then plus the 9/2 plus 4. What we have is 6. 6 plus 10/2, which is 5, times 1/2. 1/4 it is. 1/4 right there. 1/4, and what we have right here is 11/4 for our approximate area. Now, looking at this, we can see that this is concave up. Now, if this is concave up, that means these values right here are actually a little bit over the top of this value right here. So if it's concave up, the trap is going to be, actually a overestimate, overestimate of the actual value, the actual area. We can verify that in just 1 second. Okay, so we know that 11/4, is a overestimate of this value. Okay, so this is an overestimate because it's concave up. Okay, overestimate. And now we can find the actual answer, if you recall, going from 0 to 2 of x squared dx. Now, if you recall and you learned this, we know we can find the antiderivative, which is x cubed over 3. We'll integrate this from 0 to 2. We'll have 8/3. You plug in the upper limit in there. If you forgot that, we'll take this right here. We'll go 2 cubed, and then we'll plug in 0 cubed over 3. And what we have is 8/3. If you plug that in there, we know that 11 divided by 4 is going to be 2. 2.75, and 8 divided by 3 is 2.6. So you can verify that, yes, it is an overestimate. This one is slightly larger than 8/3, which is the actual area. All right, so trapezoidal rule. Essentially, you're creating different trapezoids, along an interval. Like the Riemann sums, you need to figure out your height, which is your delta x. You have 1/2 because it's the area of a trapezoid, and then you have base 1 plus base 2. You can do these individually and find each one individually, or if they are uniform, you can factor out, the 1/2 in the height, which is this right here, and then you can take f0, the two endpoints are going to be the same, but then take the middle values you have here and multiply them by 2. Another little trick that you may or may not know, is actually, the trapezoidal rule is actually the average of the left Riemann sum, and the right Riemann sum, and it's the average of those two. If you wanted to know that, is another little trick that you can do as well. I hope this helps you out. I'm going to do one more video on the trapezoidal rule, but good luck and God bless in the rest of your problems.